All right, so that was the hard problem, I think, the one we had, which is the nth digit. I think that was one is honestly the hardest one in this program. So now we're going to move on to updateTally. And before we do, I want to kind of go to the objective of this, which is we're examining a phenomenon called Benford's Law, which basically says that, or the first digit law, law of anomalous number, it says in many real-life data sets, many, not all, many, the leading digit of those numbers is most likely 1. In other words, n is equal to 0 in nth digit. If we were to track that across all the numbers, the most common number would be 1, right? Then 2, then 3, then 4. And that's just kind of the distribution in any kind of data, in a lot of real-world data sets. Okay. 0 is never going to be a leading digit because 0 is never a leading digit in numbers that are written out normally, right? We always write numbers, we would never, we write 100 like this, we never write it like this or this, right? So that's why it's never a leading digit. So we're saying we're more likely to see 100 over here than we are to see 900 in a data set. Or rather, no, that's not what we're saying at all. We're saying we're more likely to see 1s as leading digits than we are to see 9s as leading digits. Okay? Why? Feel free to read the Wikipedia article yourself or other reasons, but what it comes down to in my kind of logic is that the 1s have more chances because as you go right from, say you've got a data set that's mostly in thousands but with a couple of stuff in the 10,000s, those thousands are more common, but if it's a data set where things are like dispersed in like a normal distribution, the 10,000s are going to occur a bit more than like the 20,000s if it's mainly centered in the thousands. So but we're not interested in why. We're interested in examining, does this occur? We're interested in seeing, okay, I'm going to grab a data set and see how this occur. Does this occur? So to do that, we need to keep it. We need to basically get a data set of numbers, okay, which is we'll do in a bit, or you'll do that in a bit. And then what we need to do is we need to make a tally and keep a tally of all of the times we see a digit. And that's what this one is doing. What this problem is doing. Suppose we basically, so we're keeping track of the number of zeros we've seen, the number of ones we've seen, the number of twos we've seen. So this tally says we've seen 0 zeros as a digit, we've seen 0 ones, we've seen 1 2, we've seen 2 3s, 0 4s, 0 5s, 3 6s, 0 7s, 9 8s as a digit, and 0 9s. And so what we're doing is we're going to say, okay, here's the current running tally, okay, and I would like to see, for this number, I'd like to increase the tally by looking at the digit at n equals 2. In other words, this digit. And we'll see, okay, we initially started by seeing 0 7s. We look for n is equal to 2. We now have 1 7. Okay? Similarly, if we start with this tally over here, we go from seeing 1 2 to seeing, okay, index z. We're looking at the first digit now. There's a 2 there, so we're seeing 1 2, and we go to 2 2s now. Okay? So we're making this method be flexible, which means it can keep track of any digit, right? We can look at any digit. But in reality, we're pretty much only going to be looking at the 0th digit, that very first one. Okay, so let's go ahead and write this function, okay? We'll start by writing the signature, public, static, void. Void? Why void? Because I said so. I'm reminding you here. because we are modifying tally, it's going to be a void method that returns nothing. So this is a reminder here to remind you how programming languages work for the most part, that they are pass by copy. Pretty much every programming language out there is a pass by copy language. Okay, so, and what does that mean? When we were changing num over here in this problem or this problem, we didn't have to worry about it because this number is a copy of whatever we pass in. When we create functions, we're always we're passing in a copy of these values. Okay, and that's how function calls always work. Okay, we pass in a copy of int n, we pass in we copy this number, and for the array, well, that's where it kind of becomes a bit deceptive. Here, we are copying the memory location of this array. So the way it works in Java is that when you copy something, you copy what's stored in the variable. In integers, doubles, floats, basically all your primitives, what's stored in these variables is the literal value. But for anything else, like strings, arrays, or as we'll see, objects, like your scanner, what gets stored in the variable isn't the whole object, it's the memory location of that object. Why? Well, I'm just passing in honestly, this array tally, this array integer of arrays, this array of integers isn't that long. It's not that big. It's 10 integers. Not that big at all. But what if it was? What if it was like a million integers or a billion? That would be a lot of stuff to copy. So, for the sake of speed, and basically when programming languages like C got designed, they're like, we're going to just pass where we find this. We're going to copy where we find this. Okay? Rather than doing a deep copy, literally copying everything over, because that would take a lot of time to have to keep copying everything. Okay? And for consistency's sake, that's how most programming languages work. Okay? So, they're passed by copy. That means, though, we don't really have to worry about modifying these things. But if we modify an object, or modify what's inside of an object, inside a function, that's going to just persist. That change will persist. Whereas changing these primitive values won't persist. Okay. That is just something that is one of those things that you kind of just intuitively will kind of just get a handle on as you practice more and more. So update tally. So what we are doing is that we're given this tally, right? We basically want to increment the digit stored in here. We want to increment a single digit stored in here. Specifically, given this number, and let's say we're given 0. We want to look at we want to look at this number's first digit and say, aha, whatever that is, we're going to increment that value. We're going to increment the number of times we've seen that value. So here, this array, why are we using an array here? Because we kind of need to hold 10 variables, right? This is a count. This tally is keeping count of how many times we've seen that particular value as a digit. So we've seen 0 times as a digit. We've seen 1 0 times as a digit. We've seen 2 1 time as a digit. So index 0 holds the number of times we've seen 0. Index 1 holds the number of times I've seen 1. Index 2 holds the number of times I've seen 2. So let's go ahead and get that, and let's go ahead and get to it. So the first thing we need to do is get the number at this location. Get this nth digit. And we have a function for that, nth digit. So what is the digit? So what is the value in this nth digit? Okay, so that is the value. Okay. And then actually that's most of the problem there. Honestly, this is going to be a lot. This problem was a lot more of me talking than solving. Okay, this value corresponds this value corresponds to one of the 10 indexes in there, right? If we passed in 2 and so if we passed in 0 and because most of the time it will be 0, then this will return 1 in that case. And then we'd want to take this tally of values, right, which might look something like this. Might look like A, B, C, D, ... And basically you'd want to modify this so that it would be A, B plus 1, C, D, ... So how do we do that? Well, we know what the index is. What? So we go to the index that corresponds to that value, and then we just increment it. Right? This value, so again, if we wanted to go, if we saw 1, this would get us to index 1, and then we just would increment that value. Or we could just simply say, or if we need to break this up a bit further, int prev count is equal to, right? So that what I wrote earlier was completely correct, completely and fully correct. But let's say we need to figure out this a bit more, right? If we wanted to basically be more exacting and don't mind wasting things, int value, right? The index we want to go to and increment is the same as the value that we found, and then the value we want to store in there, well, we got to figure that out. We're going to figure it out by saying what is the previous count of that index. Okay? And then what we want to do is that we want to simply take that value and that's if I want to just completely just elongate it. We could, again, we could and we did make it very short, much shorter. Okay. And we do that over here. Right? You can ignore all the commented out code, but that's all you need to do for that one. All right. Because I'm probably not recording a video on this next one, let's now nth digit tally. You're going to basically be given a bunch of numbers, such as the data set, okay? And what we do is that we create that tally starting from scratch, okay? That is worth its separate video, but basically you're going to, for each of these numbers, call updateTally once for each of those numbers. Okay. So as you can see, what's going on here is that every function is essentially calling the previous function you wrote. Okay. For this one, again, you'll be using scanner to read the data. The annoying thing here for scanner, as I just wanted to mention, is that you'll need to do it twice, essentially. You'll need to read your file. If you've got a file, you'll need to read it twice. Once to figure out how many numbers you want to store, and then once again to actually read the number, to read the actual numbers. That's if you want to just simply use only what we know. Normally you don't have to read a file twice. Normally you'll just simply use an array list, but you don't know what an array list in this case is. So anyway, that's, I think, good for now.